Yes, everyone is usually surprised about hearing earthen architecture in Norway, but there's a lot of buildings. I will present 4 cases, and I'm looking for the health of the old buildings. And in the way the doctor, I'm architect engineer, but I look at the patients. And the 4th case, I'm asking everyone, do we have an active dialogue, to give me your theory, what is wrong with the plaster on the biggest earthen construction in Norway, and how can we solve the problem? Because they tried to solve the problems in the 1980s, and now we are still working on the problems, and you will see the damage that I'm going to show you. The first I want to start with is that building here. Everyone may think this must be somewhere in on Cyprus or in Morocco or wherever, but it is actually in Sweden. And here I want to focus on the problem of transferring architecture in modern times from the sites where they have been built in their climatic situational context and to move them up to the north, because the topic is to look at the climate conditions for earthen constructions in Scandinavia. And this was done by a great architect, Norwegian architect Sverre Fein, and he went to Morocco in 1952 and took his impression from Morocco back to Norway. He was a professor at the architect school in Oslo, took some students in 1992 and built this light straw clay construction. There's 90% straw, 10% clay. To start with, here we have the problems with the roof. So you know the big hut on the earthen construction is this old story and the good foundation. Here the foundation and the roof is the problems. So they had a lot of repair, and I studied the problems. What can you do? You need a lot of maintenance, because you can't change the architecture, then the great architecture is gone. So it's an interesting start to see how we need to build and to protect earthen constructions in Scandinavia, finding rules, recommendations, technical instructions. And that's what we're doing at the moment. So, I think, where's the slide? Enter. Yeah. Here is an interesting, I'm talking about the surface protection. This the picture on the left side is from an advertisement of the best painting, the best protection you can have. And when you see the reality, it just takes a couple of years, then the surface is damaged. It's an old concrete construction, because these are the conditions when you ride to the Atlantic Ocean. So if you're making it there, you will make it anywhere in the world. So it's really tough conditions. Yeah, the next project is what a wonderful start. It's an actual problem. Maybe it becomes a legal issue. It's my colleague Maxwell Rodencal, coming from United States, specialist on young architect from Cornell University, a specialist on rammed earth construction. He got a project to make a bench in Norwegian nature. He was the advisor, technical advisor. A gardener produced made the construction, and I have to show you. Do we get or I have to go here. This is the failure. This part, the gardener made it wrong, is a cement layer. And as you see, this is maybe from February, March, when it is changing. Maybe there was half a meter snow. You need to get the humidity out right away. It's very important building physics. And that what happened here is, my 2 other colleagues said the same. Because of this layer, the capillary power of the force of the water have been still in the construction, and then you can these severe frost damages. So now we hope that the construction will be rebuilt, but at the moment it's the responsibility of the architect, engineer office to find out that they have made the mistake by asking a craftsman that is not able to use this material, which needs a lot of experience, a lot of knowledge about what you can do and what you cannot do. And if you look at the, I don't know if you see it, this is the dry, this is what we call the dry foundation, tørrmur in Norwegian. That means that the capillary forces are not going up, and when you lay the cement layer here, you destroy the whole construction. So you will learn a lot about the problems that you can make, and you have a good construction, a nice design, but it is not working because of simple mistakes or misunderstandings. And the problem is he never followed the instructions by the drawings. So that is the problem at the moment. I learned a lot from this fantastic 3-bint encyclopedia, where you can study local architecture all over the world. You can find the Norwegian on Cyprus, in Turkey, wherever in the world, and then you can look at the premises to make your solutions and what you can do and what you cannot do. And of course, we are nearly in polar climate. I will show earthen construction in polar climate. It works, but you have to take care of actually 2 simple things. It is the good foundation, the dry foundation, the capillary functions of humidity, water getting out, and the hat. And the hat is a problem in modern architecture, as we see in the first example, where we transfer the Moroccan-inspired architecture to Sweden. Even in Sweden, it does not work. We have a very few constructions which have no surface drains. What is common here all over. It's mostly agricultural buildings, so this is mostly from the 1920s and 30s. Today you will not find them because of the maintenance, which is very intense. They changed the construction using wooden panels, or they put lime on and so on. So you will not find any open earthen surface, which is also now en vogue, you can say, all over the world, but when you're coming to Scandinavia and the Nordic climate, it's nearly impossible, or you need really very strict maintenance routines. It's inspired mostly in Norway from Great Britain. It's from a book usually to, you see here, cottage building, and it's got via Sweden to Norway. Sweden has some influence from Germany, I will show, and from France, because of the French king that was in the system, and they have this knowledge. You see, this is the situation when you have the loss of maintenance in Norway. We see actually the most common protection, which is wood tar and lime on the top. I will show you in the 4 cases where it works and where it not works. So this is the typical situation when you're coming to most agriculture building all over the country. So you see, you can repair it, it's working very well, but the lime on the earthen construction is a challenge because of the humidity, especially because of the humidity in Nordic climate. All of the knowledge and all of the inspiration and the architecture was coming by Sweden. So here we see that in Sweden, it's in Swedish, it's from the beginning of the 17th century. In Norway, we find mostly architecture from the middle of the 1800th century. So it was first in Sweden, and then it came to Norway, which was actually a common kingdom, and it came up in the beginning from Denmark. Here we see the repair of a very thick layer of lime plaster, which we get in the 4th case to look at. This is the attraction in Scandinavian or in world context. It is the most northern rammed earth country ever built. It is north of the polar circle. I will show it on the last slide. And it is said that it was paneled with wood, but here we see it is still, it's not here, next one, it's still open rammed earth construction. Unfortunately, it was damaged under World War II. Actually, that we would have the most northern rammed earth construction by a wonderful, this pioneer here, that built this house. It was the third attempt. It had older houses that burned down, but at the first time he built it again in a wooden construction. But this was unfortunately the rest. There should have been cultural heritage, of course, but it's very special because it's even survived this burning, you know, the burning when the German troops left and the Russian came in, or Soviet came in, and they burned it, unfortunately. So that's the first case. I show always, and I start always my research, or the doctor is looking at the patient, I look at the site. So I want to know where is the most difficult part of the building, because most of the climatic press is coming from the southwest. So when someone sent you a photograph, oh, the house is wonderful, from the northeast, it will always look much better than on the southwest. And it's here the right thing. You saw it. It's now we're on the southwest of the building. And there are the biggest damages. And there were some failures in the construction. But the biggest problem was that they changed from the natural materials that are breathing, that are capillary on top, to cement-based layers, mortar, or painting. So we decided to remove the complete damaged parts where there's cement in it and put in earth again from the ground or from near the ground. It's from the ground. Then we looked at the original description. It's one of the best described project we have in Norway because it was a journalist. We know every detail. And he was writing, I took the layer of wood tar. At this time it was in 1952, I think it was stone coal tar, but he used tar as a first layer. So we painted it again with tar, and then we put on, which is very special, it's not the usual thing, it's usually lime, with cod liver oil with a natural pigment from the district, which is this what we call this typical red from Scandinavia. So this works very well. It is this photograph shows the building, I think now 6 or 7 years after repair, and now it is about 12, 15 years, and it's perfectly, we have only very small cracks. So we did that what we say, the craftsman, when we see that something works, we just repeat it. No improvements, nothing, no reinforcement, because this will work. There was a green roof, it was too heavy, and it was replaced, so now we have not this force anymore. So there are a lot of details you have to study, and the last one you will see, it's not easy. Here are the 11 houses from 1870-72 at Frølisbyen in Oslo, in the capital. And we see here some improvements, layers that are too dense. There are plastic inside, and they're painted with something that is not letting the vapor and the humidity out. That means high risk when it is in spring, and you have this moving from 0 degrees when it's freezing, and then the construction usually collapses. So here it was an interesting thing that I always tell, when you have such a project, you have to take care of it, get in contact with the owner and ask them everything they know, especially of the time they can remember from the last 50 or 75 years. Is anyone seeing a difference between the buildings? I didn't recognize it, but I heard it last year. We had a meeting with all the owners. They're very proud owners, very expensive buildings in the capital. Look at the roof. Look at the hut. Look there. They changed the roof of design reasons, we believe, in the early, maybe 1970s, and that made the facade, the lime plaster, crash. So because there was because it's also in a way to the other side. It's always southwest. So it's one facade that got too much pressure on it, and it collapsed. So today, I should have this later. You see, the roof is out again. So they made it like it was in 1872, and now it works very well. The facade is well functioning. Here we can see the the thick layer of lime, which is stabilized with some reed. And I could show you, you see the nail here? Yes. Should show you there. So it's stabilized and it's working very well on all these 11 buildings. And it's a special, they call it the wind-dried adobe stone with small particles of sawdust and wood in it, which is actually a very Norwegian way because we have this wooden cultural heritage, so that is a natural thing to stabilize or make the stones slide. That was done in 1872. This is the third case, which is also very unusual because here is the only example. Yeah, I tried to make that faster. Here's the only example where where a cement-based layer, 2-3 millimeter, works perfectly on the earthen wall. Here you see one part was demolished because of a new building on the site. Here you see the sample where I take out. This one was a lime wash in the old times. This picture up there. And you see inside down there, you see the rammed earth wall. And last year I took this sample here where you see the lime wash. Then there is 2-3 millimeters of cement based kind of a wash too, or I don't know how they made it. And it's a perfect facade, no cracks, nothing. It works wonderful. It's a very low amount of clay in the rammed earth. So my theory is then it works together because clay, of course, is a Nordic climate. The factor that makes the humidity in and it attracts the humidity and may cause the problem. Here's the case 4, and now it's you can tell me the next days what shall we do? So we don't know. So this is the biggest rammed earth construction. We don't know exactly where they started it because we have no information about the building process, only people that remember it. But we have a painting which shows it 1837, so we believe that's about 1811, but we will make a dendrochronology on hopefully one day to get an exact datum, and it will be also a very old building. So you see the same. Here you will see mostly now photographs of the southwest again, even if we're on close to the Swedish border. I will show it in the last one. When it was the summer castle of the German-born Queen Sophie from the King Oscar in Sweden, where Sweden and Norway were together, 1814 to 1905, then it stops. So it's also like the castle of the king in Oslo, because one of the biggest rooms, that's the one on the left side, is the completely copy of the original room that you have in the castle. So it's the dream of Cointreau, you know, of this time when they just made, you can build actually wonderful modern architecture, not modern architecture, but the manor houses with this material. So here the problem started in the 1940s, 50s. The owner then had not enough money to take care of, and the problem started. Here we see that it was originally built exactly by this academic architecture, they call it, not vernacular architecture, by David Gelli. You see the construction here, you see exactly, completely, and it is a hybrid construction. You see the adobe stones here and the rammed earth down under there. It was wonderful to find it because it had never been there before. It is highest protection cultural heritage, and the owner was not that kind with authorities. And I also thought, but it's another site in Norway, so we made it we've come from the ICOMOS and asked him, and then we got this wonderful opportunity. Here you see, I studied the old literature. What are they telling us about solving this problem, lime plaster on earthen walls? And you can find it from Solomon Sachs. He writes exactly many things about it, especially about lime production. He said the quality is very, very, very important. It's old literature, and it's in Gelli, and it's Cointreau's literature. You see here the attempt in 1983-84.
which went wrong. They tried to stabilize with mesh, with the what's it called? Yeah, these small meshes. It's too stable, so the cracks just continue. And you see now the situation on the inside is much better. You know, yeah, I try. It's on the inside, it's much better than on the outside. But here you see the trouble. So it's still looking like that, and you can show you, this is the on the cellar where we see the original construction. There were a lot of theories about, is it rammed earth or is it adobe, because when one person started above, he only saw the adobe stones. There's everything adobe, but it's a very smart construction, because to ram the earth in the roof, it's much better to do it that way. So it's wonderful to learn from this. So here's only one example. When they repaired in 1983 to 84, they just looked at the sand corn size, but not at the character of the sand corn. So we need all the time to learn to find the right treatment for the building. So they forgot that, or they couldn't imagine that it could have an thing. And of course, it's also in the clay particles. They connect when they're not in a way polished, or they're moved when they're staying the same with sand. So I can just read my observation of all the cases. The right technique depends on the site and its local climate conditions, the type of earthen construction, amount of clay, humidity, behavior, the bonding between earthen surface and plaster, thickness, quality of lime. Recommended historically and found in Norwegian rules, instructions, sand, you throw sand on wood, tar, when you have freshly painted the earthen wall as first layer. And then you can put on lime or another natural linseed oil or the cod liver oil. Any type of cement, an amount as mortar or painting, is a high-risk use in most cases. Strict maintenance routines are essential care of the earthen construction's durability. Craftsman, craft skill, building material understanding and experience is necessary. So you see the most northern is the polar circle. It's the Fosley house. Then we have some in the Samic Omre in Kautokeino. This is the tannery. This is the tannery in Trondheim. This is some project near Bergen, and here is the biggest earthen construction is the Skinnaburg Castle, and we have some in the Frölichbüren, and we have some other project in the 1950s, and mostly they are all with a tar, or they are later repaired. Some are working with cement layer, cement painting, others not. So it's still ongoing research. What is the right way to make instructions for building lore in Norway again? The old ones from the 1950s, they said use tar, wood tar, sand, and lime. Thank you very much.